This one here, you notice, what do you have? Make a list of what you have here. You have A is 4. Do you have the ratio? You can figure out the ratio. Take any two terms and divide them for the ratio. So the second term is negative 12. The first term is that, so it's negative 3 is the ratio. Notice that the ratio is negative. Ratio is negative here, right? Because the terms alternate. Do we have N? No, right? Do we have L? Yeah, we do. The last term is negative 8748. These formula, and which is the one we're looking for? It says find the sum, so we want S, and we want that one. If we have these three, pick the formula that makes sense to use for that. Well, if we don't have N, but we do have L, this is the one we have to use, right? You could work out what the number is using what we did previously. You could say if this is term N, I can work out what the number of terms is, okay? Or a bit longer, but find N, then use the first formula. There's more than one way to do it here, okay? Or you can just directly say A minus LR over 1 minus R. Notice that one of them does not have brackets in it. One of them does. I think the real learning has to happen here. This part, I don't need to show you a bunch of examples of this because that's the simplest part here. You might have to sometimes work out, might be a kind of a two-stage process here. You might have to work out other things first, but it's as soon as you have a problem like this that the real thinking starts to happen here, or is required, I think. Let's think about this situation here. Hopefully we can actually reenact this somehow. Let's see what we have in here. We'll try these three things here. Okay? I'm not going to juggle, no. It's now a golf ball on top of a 100-meter building would be a little bit more spectacular and maybe wouldn't even bounce. I don't know. I guess it would off pavement, wouldn't it? They're pretty solid. If you drop this, think about what's going to happen. So pretend this is a scale operation here. This is 100 meters. What happens here? And you got to count the bounces, right? Like this isn't an exponential function. The thing's obviously going to go like this, right? And bounce around. If you had to draw kind of a picture of that, that might help you figure this out. It starts up at the top here, and now you're focused on that thing because it rolled off. And it bounces up to 3/4 of its previous height. And then it's going to, except my ground's not the same level here. So it bounces off there and again and again. All right, it keeps going 1/4. The thing is, you need to count the bounces. When this, for some reason, I think people try to memorize this question, and they think, "Oh yeah, I know how to do those." Where's this thing here? They think, "I know how to do these bouncing ball questions. What was I supposed to do? I was supposed to multiply it and add this and subtract that." If I asked you, if I drop the thing and say, "How many times did it just bounce?" How many times did it just bounce? Were you watching? It bounced twice, right? This is bounce number 1 right here. The bounce is when it hits the ground. This is bounce number 2. So you have to keep that in mind because you could set this up a number of different ways. You could say that you're going to count, if this says after the 7th bounce, okay, wherever 7 is on here, you could do this a couple ways. Some people would calculate the height after the bounce. Okay, it's 100 meters before bounce number 1, right? So what's it going to be after bounce number 1? 75. There's nothing that says that you must make the number in the question the first term, right? If it says after the 7th bounce, the thing that might make the most sense is to say, I'm going to make the first term the height after the first bounce. Right? Does that make sense? So I would be saying, here's the bounce, and here's the height. Bounce number 1, it's 75. After bounce number 2, it's whatever. And you can keep working it out there. I am going to choose to say A is 75 here. Because then what's the number of terms I want here? If I want the vertical height of the ball after the 7th bounce, so this is my first term here, it's 75. Here's my second term, 3rd, 4th, 5th, 6th, 7th. I want that one, right? What n do I use here? 7, right? Somebody else might do something different and might say they're going to choose to use A is 100. What would their n be then? They would have to say 8 because they have to think through, well, this is before the first bounce. 8 is the before the 8th bounce, which is after the 7th bounce. All of those things you should put down if you're trying to solve a question like this, solve a problem like this. We know the ratio is 3/4. In this case, it's just putting the numbers in, right? Put the numbers in and figure out what it is here. Do I want T7 or S7 here in this question? I want term 7 for part A, right? It says determine the height. Okay, you want this. You can find what term 7 is. If you read part B, I'm gonna let you. Once we've done that thinking, that's the hard part, right? Plugging in the numbers isn't so hard, but determine the total vertical distance traveled by the ball when it contacts the floor for the 7th time, i.e. on the 7th bounce. So will this number that we included in the previous question, will that be included in this total? Because this happened after the 7th bounce. That one's not going to be included, right? What do we want here? Do we want term 7 or S7? What's going to help us solve the problem? This, right? We don't want that. Now, S7 isn't going to be just the answer. We're going to use S7 to get our answer. Okay, use S7 to get answer. Okay, look up at the picture here. The ball travels down, then it travels up, then it travels down. I know that's really revolutionary, and you didn't come here to learn that. But when you're solving this question, make sure you think about that. It travels up 75 and then back down 75. So on that kind of loop alone there, that's 150. So this is going to help you think about what you have to do in order to find an answer here. Again, there's several approaches. For the person that used 75 as their first term, if they find the sum of these terms here, as in if they find this, like if they find S7, it's going to be those things added together, right? So I'm going to find out what S7 is. But that's only one direction. Like that's how far it went up. It also goes down. So what would I do with that number? Times it by 2. But then what have I missed? The 100. So what can I do with that? If I started with term 1 being 75, if T1 or A equals 75, then I would do that plus 100. If I use term 1 as 100, what would I need to do here? If I set it up like this, where I started with 100 and used 8 terms, yeah, 2 times S, 8, but minus 100. Why do I minus 100 in that case? Yeah, it didn't go up to start with, right? So whichever way you do it is fine. This is going to be interesting for marking, and it's important for you to mark mark accordingly if you're marking your own or looking at things. Your answer might not look like the sample answer. These will get you to the same thing. The answer in the end's got to be the same. How many times does it need to bounce approximately? Well, that's going to be used for Sn, right? And solving for, what are we solving for here? Solve for, if it says how many times does the ball need to bounce? For n, right? I'm purposely not doing all these questions because I want you to go through and do some thinking about this. That's lots for one day. The good thing is you have 10 minutes to work on a few of these questions. We've got to use every minute we've got. Next time we're coming back to that idea of the ball bouncing, and we're going to look at what you call infinite geometric series, as in if you take the thing and you let it bounce forever. I know in reality it stops bouncing, but we're going to model it with a function that goes on forever. Okay, but that's next time.